Real quick, my name is Kazuo Scott Leslie Kuika Pelepoha Kalani Lithed Todd. I am the fire chief for the Big Island of Hawaii, and I run the Hawaii Fire Department. I'm also currently the chair for the State Fire Council. So you guys may have seen the legislation that passed recently that's going to add a state fire marshal, which we've been missing for like 40 years. So I'm sort of technically that guy right now, but with no time to actually do it, which is great that we're going to have someone that can do that for me. So today I'm actually here to talk about batteries, but I'm going to try and make this happen in about 10 minutes. And then at the end of the 10 minutes, we'll try for maybe 5 minutes of questions, and we can stay on topic. Or if you just have some random fire question you want to ask, potentially I can go into that. I'm not going to talk about nuclear for sure. Anyway, I do want to make a disclaimer. This is coming from the fire side. There are definitely people who are more in depth in terms of their battery knowledge, but from I guess the seat of a fire professional, what do we see on the batteries, and what are some of the issues that are going on right now? Let's see. Does this work? No, it doesn't. Do we have another clicker? All right, well, maybe they will just do it for me. Okay, so real quick, agenda. I'm going to talk a little about some emerging tech that's showing up in Hawaii now in terms of battery. We'll talk about some of the fire dynamics. So how does the fire start in batteries, and what are we looking for from a fire professional side of thing? The risks that firefighters are kind of seeing out there with these battery technologies that are coming out. We'll talk a little bit about the concerns in terms of firefighting and the new things that we're seeing out in the world, as well as some of the things that our consumers can do for safety reasons, as well as some of the things that those of you involved in battery energy storage systems or dealing with like home energy storage systems should be aware of in terms of fire department's regulation and emergency response, and then some closing thoughts, and then hopefully we'll get into some questions here. All right, so emerging technologies in battery right now. Right now, if you see it on television, it's in the state of Hawaii. From hoverboards to e-cigarettes to laptops running, LiPo battery systems, cell phones, electric cars. We haven't quite got the kind of density in electric cars as you have in the mainland because the infrastructure for repair isn't necessarily here, but you still see the occasional Tesla and everything out there. And so the question is with all this new technology and all these new batteries, as we're transitioning kind of our energy grid and everything else, what kind of fires are we seeing? So in the state of Hawaii, and Mo mentioned right now, well, I'll tell you some numbers and everything, they're definitely higher than that. Part of the problem with the fire investigative side is we'll go into a building, it'll be burned out, everything's black, and there'll be 5 or 6 things that might have started the fire, and there's a really good chance that maybe a battery-based thing started it, but we can't conclusively say that, so on the record, it's just undetermined. But we definitely have had at least 2 apartments in Honolulu from e-bike fires. So these e-bikes that have the batteries that are being recharged in apartments have taken out entire apartments, causing hundreds of thousands of dollars in damage. We have a lithium golf cart battery fire recently we had in Waikoloa that had taken out a house unit over there. For the last 20 years, as we've been changing our battery technology, consumer goods have been a major source of fires. These are from e-cigarettes, which we've seen on like a Hawaiian Airlines flight, as well as we've had a couple apartments that fires have started from that, to just laptop batteries that have run into issues with overheating and going off. We've also seen a lot of, I want to say, cheap consumer goods that are non-UL listed that have shown up on like Amazon. You find these products, headlamps or a variety of other things, and these products are basically some company you've never heard of, and they're being sold on Amazon, and it arrives, and as you're charging it, it gets pretty hot, right? So we've seen these start a bunch of fires. As of right now, I don't have any electric car fires on the books that we're familiar with for sure, although we have seen some issues with batteries after accidents, and heat and smoke and issues with that. And then on the battery energy storage systems, currently, while we have a lot of solar fields out there, the only fires we had were from the Kahuku wind farm back in 2011, 2012, and this was because of an ECI capacitor issue, which looked to be like a faulty design in that particular one. So these are some of the fires that we're seeing in Hawaii. We'll talk a little bit about fire dynamics and behavior. One of the major issues with it is that as the energy density increases due to the internal chemistry of the battery, the more energy it stores, oftentimes the more volatile it is and more potential it has to basically have thermal runaway. So the biggest issue from a fire perspective is thermal runaway, because at a certain point, at a certain temperature, the battery hits a temperature where it's just not going to cool down on its own through the normal battery management systems or anything else. It's going to need external cooling. Otherwise, it's going to just keep on skyrocketing up until it's on fire, and then you have that thermal runaway propagate from battery to battery, and then now we've got a battery, whether it be in a laptop or a cell phone or an e-cigarette or a full-on 40-foot container on fire. And so these are the things that, from our perspective, are kind of a concern. There's a variety of different chemistries. There's about 6 major chemistries that are being used in the lithium batteries, which are pretty much taking over the industry right now. I went upstairs. The one I like the most currently as a fire chief is the LFP technology or chemistry, which is our lithium iron phosphates. It has a higher thermal temperature before it'll hit thermal runaway, about 270 degrees Celsius, versus our NMC technologies, which you see in like the Tesla wall and the Tesla car, which is around 210 degrees Celsius. So there's some benefit in that. But the basic thing is there's a variety of ways that these issues can propagate and become a problem for the fire department from a fire perspective. Primarily, when we talk about it, the problem lies in damage to the battery itself. So this could be because of charging cycles where the battery itself chemically changes and has the ability to kind of grow these spurs, which will allow it to short circuit. It can be a matter of mechanical damage. So one of the things we've seen is like Tesla cars. They get in a car accident and they can catch on fire because the battery itself has been impinged on mechanically, and now it's creating its own short circuit. That short circuit starts basically a reaction that starts the thermal runaway process, and it catches fire. We've also seen that process not even start until 7 days later. So the car's parked in a dump yard or whatever, and then like a week after the accident, now it's on fire. And one of the bigger issues we've seen is the amount of energy in these batteries makes fire suppression a real issue. We're seeing on some of these Tesla cars up to 30,000 gallons in the middle of the highway applied for like 3 hours before the battery is not on fire anymore. So there's difficulty in that in terms of dealing with it. But definitely, I think, from a fire professional, one of the biggest things we're seeing is we're seeing a lot of houses move over to these home storage systems as a solutions for grid sufficiency and whatnot. I know there's 3 companies upstairs, which I won't name because I don't want to make one of them unhappy or something. But I've seen a lot of those out there, and they are pretty interesting. We haven't seen any of the LFP type batteries burn yet, but we have seen some of the Powerwall or their equivalent, which are running NMC type chemistry on the internals. And those have been some pretty interesting fires. And like the whole house starts shorting out, and then like all of a sudden the outside of the house, the Powerwall or equivalent thing is on fire. So kind of an interesting thing. Basically the long and short of that is the higher the density of energy storage in the battery, the more volatile it is, and should it take that damage, should there be a short circuit, should it be installed incorrectly, those things are more likely to be volatile and lead to problems. Good battery energy storage system management within the design is usually pretty safe. In fact, some of the stuff coming out of Sweden that we've seen, I think it's Sweden, shows that on the car batteries, we're seeing about 4 times less fires than they've seen on normal combustion engines. But one caveat to that, they don't know if that's arson related too. So give that a potential other issues there. So some of the concerns are basically, of course, the amount of water that we're putting. We can actually put out a fire, load it up, and then it can reignite itself, because that chemical chain reaction that's basically moving energy from the short circuit will be continuing even after we've cooled it, and it can reignite. So we've seen this on one of the Teslas in the mainland where they put out the fire, they loaded it up into the back of the flatbed to take it into the facility that they're going to store it at, and then it re-caught fire on top of the flatbed. They had to drop it in a different intersection and then restart the firefighting process all over again. So some of the things that we've been doing with these is that there's new firefighting techniques coming out in terms of like blankets, which just sounds really weird, but they're selling these blankets that we basically would take and cover the car with, and then starve it of oxygen, which doesn't tell me like how long we have to leave it there. So I'm not quite sold on that technology, because the short circuit's still happening. It's still producing heat. It's just not burning because there's not an access to oxygen. But that process is going to continue until basically, the battery stabilizes, which is when, right? And so while, that's one of the things being pitched on the industry, one of the other ones is a plug that you can plug into the car that basically tells the car that it doesn't have any power, which I'm also not 100% sure works because it still has power. But there's a variety of ways those things work, and so we've been looking at that from the fire perspective. One of the other issues that becomes an issue is, when these batteries are burning, there's some rare earth metals, there's different composites, a lot of plastic, and so there's a lot of toxic gases, forever chemicals, all kinds of other stuff coming off of them. They're also known to be extremely hot, and our ability to get in and actually attack the fire is difficult and potentially opens us up to electrocution or things like that. So we found, at least on like our consumer product car market where that have these batteries, it's kind of a difficult thing. Getting it hauled off of the road and letting it burn and basically being there and spraying water on it for a long time seems to be the way the industry is going at the moment. We've also seen explosions on battery energy storage systems. We had one in the mainland in one of our NFPA journals. They'd had a thermal runaway issue on one of the lithium battery energy storage systems up there, and basically it had a FM200 system, but once they opened the door to let the heat out, eventually it did ignite and blew up the entire facility. One of our issues on the other side is that USBs are universal, but the chargers that a lot of these products come with are supposed to be at a certain amperage and voltage, and people will plug them into things that are pumping way too much power into these devices, and they're like, oh, it's faster, it's charging faster, but the battery management system is not designed for that. And they have a lot of knockoff foreign products that haven't gone through UL listing and whatnot, so we're seeing issues with that as well. For those of you involved in the battery energy storage system, my main takeaway from here is have an emergency response plan. It is technically required by NFPA 855, but work with your local fire department because we're going to be responding on what is the plan. Are we letting the facility burn? Are we providing water? What are your safety facilities? And fire can come from two different ways. One, it could be something internal. There's a problem with the battery energy storage. Or it could be wildland cause, where fire is intruding onto your property. And you need to have a plan for both sides. How are you going to maintain your land to make sure that fire doesn't impinge upon your stuff and then start it on fire? And then how are you managing your own systems and what kind of technologies and fire-resistive properties are you going to be built into the things that you deploy? And that kind of covers the BES response side of things. Note the major ones are the UL 9450A, which covers thermal runaway and testing, and NFPA 855, and then our normal industry standards in terms of electrical code, building code, Department of Transportation standards and whatnot. And then make sure you're always working with your fire department on the wildland fire planning and vegetation. And as a conclusion and a takeaway, some of the data coming out of Sweden showed that it seems like the technology is basically pretty safe and actually safer than other things. It's just that the fire departments and your emergency responders aren't used to them. I know like 15 years ago when solar was going in, it was like the biggest concern for the fire department. So conversations, meetings, talking with your local fire department who's going to respond, those are really important things to get them to feel comfortable. Because like we might have an ability to block your plan set as it comes through the building department or something. So you want to make sure that you have those conversations ahead of time. But generally, the numbers coming out of it look like this would be a better in the long run kind of a solution in terms of us moving over to battery-based technology. And that kind of covers it. In case there's any questions, I have 1 minute left. All right. Well, since you guys don't have any questions, you guys have a wonderful day. Thank you all for considering our energy future in the state of Hawaii. And if you see me around and you want to ask a question later on, just hit me up. All right?